Good. So first thing is image. Oh, hang on. We need a new file. Okay, new file. Image, and now the right option, create a planar image, and the 3D axis. We go to Documents, Cat, Rolex, Baguette, Winding Stitch. There's our photo, and we import that into the XY plane. Way too big, so we just, to test it out, go 20 by 14, just for the heck of it, and that we already have a pretty decent image here. So now we need a sketch to get the grid. So we just go into normal part design, do a body, and start a sketch in the body. Again, XY, so in the same plane as the part is. And now we modify, so we go back to the sketch, go to the view, and set our grid size to 1 millimeter. So now we're talking. Control plus zooms in. And now we can see we're way out with the image size. So the image is way too small. The grid here is a millimeter, and we can fit almost 2 millimeters, 1.8 millimeters of the photo in there. So we go to data and go to 30, just for the heck of it. I'll put that to 20 just to get a bit in. And now we see we're still too small. Yeah, the grid is still way bigger than that. Let's go to 40 and 30 for the heck of it. And now we're too big. Yeah? They run slightly, they're slightly too big. Not a lot. Let's go to 38 and see what it does. And we're not doing too badly here. Still too big. Yeah? 36, 36 millimeter, and slightly, I would say now the grid is a bit too big. Actually, it's a tiny bit too big, the grid, I would say. Yeah. Let's try making the photo a tiny bit bigger. Yeah. So 36.5. That looks very good. That looks very good. Okay. And now the trick to get the Y size, we need to know the dimensions of the photo. So we right click on the photo, go to Properties, Image. And that gives us the numbers 2560 by 1920. So we just get a calculator out and go 36.5 times 1920 divide, 36.5 times 1920 divided by 2560, and that is 27.375, and now we're absolutely perfectly to size. What we also notice is we're slightly tilted to the left. So we got to turn this thing clockwise. So we go to Placement, Angle, and give it 1 degree. Oh, we got to go negative. So minus 2.5, minus 3. Perfect. Look, the lines here are just so. If anything, a tiny bit higher on the right. 3.1. 2, 3, 4. That's perfect. Yep. If you look at the line here and the line there, compared to the start of the hole, I think we're really spot on. What I would also like to do is put us in the center. Because we want the hole in the center to be in the center. So what we got to do position-wise is we got to move X over. Oop. 0.2, 0.8, 0.7. I'm going by the center of the holds here, yeah?
Right, so you're getting these two.
Yeah. Pretty much there, I would say. No, let's go with that. So we haven't saved yet, so it would be a good idea at this point to save the blight baguette winding stem bridge, winding stem bridge, and we're safe. Good. And now we go to our sketch, and we got to start drawing. This is a pretty complex shape. What we see is most of this stuff is actually parts of a circle. There are arches. I think we'll zoom out a bit, because I want to start at the bottom here with the bottom arch. So I just take a segment of a circle and I go pretty far down. We want the center. So we want to make everything centered around the middle of the drawing. Actually, I'm wondering if you should move the drawing up. We will actually do that. I will do that. Let's go to the image plane again, and let's go to the Y position and move it up. Yeah, that holds are the whole center sit on the x-axis.
Yeah.
I think that's pretty much there. Yeah?
Yeah.
And now we go back to the sketch design. Okay. And as you see, sometimes this thing loses. We now have a 10 mil grid. We don't have a 1 mil grid anymore.
Yeah,
it's lost that. It just does that sometimes. No problem. You go back to the view and you just say, look, I really want that 1 mil grid again. And we're there. Now Control Plus gets us in, bit out. Okay. And now we start with our segment. So we know we want to hit the center line with that. And then it will start. If you prolong this will be the center of the hole, yeah, where the arch starts. We go here, and the same thing here. The center of the hole will be the end of the segment. We go here. And now we zoom in. And now we can correct, if we let's see if we got this right. What I suggest, I think it's a tiny bit too far in.
Yeah.
So what we do is now we control the radius. It's 5.81. Let's go 5.8 and see what happens. 5.5 to make that extreme. That was very extreme. 5.77. Yeah, that's it. Yeah?
Yeah.
That looks very good. Okay, so the next bit is we have this out here is just, again, part of a circle with the center of our hole, which is roughly here. So we need two circles. One is, but the outer one actually, we'll find out. So again, we choose segment, and let's put it in the center of the circle, and we'll find out if that's correct or not. The end is always, so this is the point where the new arch up here starts. So this one ends here, and the new arch starts there. Yeah?
Yeah.
So we will try and hit the end here. And we go around, and we can already see we're totally off. But I'm going to make it join the dot here. Okay, so what that does, it moves this line. Now we have to move the center of the circle. Actually, I'm going to undo this because I want to fix that line. I know that line is correct.
Yeah.
I'm going to fix this totally. So so I can't move anymore. I'm going to fix the length of it.
Yeah.
Nope. Too much selected. Dot, and fix length. And I'm going to fix this to the center line, to the X line. Good. And we could, on top of that, fix this to the y-axis. And then that point can't move anymore, because that's important. If we add other stuff and we muck around with the circle, we don't want this to move.
Yeah.
And now we can play with this arch. We can basically force a join now. So I select the 2
Wow.
points, and I will say there's a constraint with these 2 points, and boop, it moves up. Beautiful. But we can see this is totally wrong. The radius has to be more,
Yeah.
and the center is not the center of this hole. It's not. So what we see now, we have the beauty of being able to change all this, and it's not going to muck up our base arch. Okay, but we gotta go out here. Yeah. Okay, like this and like that. The top point doesn't want to go up if I force it. Because there's a constraint here. We have a constraint, this constraint here. Yeah. If I go to the constraint, it says the point sits on the x-axis. We're going to delete the constraint. That's why I can't move this point up. Now that the constraint is deleted, see? I can move the point up.
Yeah.
And that's exactly what I want. Which is a funny thing that they constructed it that way, because you can see it's slightly off. But that's the way it is. We live with that. No problem, really. And now we say this is right. We don't want to muck with this anymore. We fix the radius, 0.8 millimeter, done. We could also fix the center to the x-axis. The thing there is we want to avoid, if we add other elements, that if we move them, that they will muck up what we have, because what we have is right. We know this is correct. Okay. Now we can go in for the circle. So we have a circle here. Did you measure the screw there?
Yeah, I measured the screw head and the screw thread.
What's the thread?
0.6.
Okay, so we have needed 0.3 radius and a tiny bit more. I'm not quite exactly in the middle. Okay, if you look at it, you can see the circle is a bit too far to the left. I'm going to move it over a tiny bit to the right.
Yep.
And that's correct. And you can see our X line, we really got that right. The photo is super centered. The center of the holes is exactly on the X-axis. That's what we wanted to achieve. And we already automatically got a constraint here. So the center of the circle is already constrained to the X-axis. That's not going to move. The funny thing is we have a radius here now of 0.38. It's a lot. Let's see what 0.35 looks like. It's not bad. In the end, of course, this also goes down at an angle, probably at 30 degrees or something like that. That's where the screw is sunk in.
Yeah.
Okay, so that's not bad. We could
It's a really quite odd-shaped head, the screw. It's really corned.
Yeah. Okay, it's very. So we got to try and guess that correctly. Yeah. Okay. While we're at it, we know it's 0.35. We might as well put our second circle here. Yeah, because we can then also give it the 0.35. So we put it here. It's 0.35. Hit it. Nail on the head. And it already has the constraint. Now, out of curiosity, we're going to fix the length here, because I want to know if they're the same. 2.05 on this side, and on that side, hopefully something very, very similar. 2.04. I can live with that.
So the distance of the center of the circle.
But this is now where I would say we want to make that the same. In the end, we have to produce a symmetric object. And the original part might not be that perfect, but we want to, if we can, we want to get better, and we want that hole in the middle to be also right in the middle. So what we got to do here is, my power is running low. Okay, so we want to make the 204 here. I'll just take that out so we can see that, and the 205 there, the same. So I would say we go for 2035, 2045 each side. Yeah, let's try that. 2045, and we do the same here. 2045, and visually we can't even see the difference. Yeah, but we're making sure we've got a symmetric object.
Yeah.
So there you go. That's good. And of course, what counts is here the circle. We could, if we wanted to, just to show a bit of being anal. I haven't done that yet. So next step here is.
I measured about 4 millimeters between the holes. So
Okay.
that'll be right.
Good morning.
Well, we have
Hi,
4 point.
Yeah.
And you?
Let's just stop the point. Good. So next step, we can do the radius here on that side, and then we'll start joining up. We know that the center here was a bit out from the other center, so we'll basically start at roughly the same point as the center.
Yeah.
Oh, I don't want a circle, I want a segment. There you go. So we start off roughly at the same point and hit the dot here that we join to that, and we go around, and you see on this side, it's quite different actually, which is odd, but I'm not totally surprised that this isn't symmetrical. What we do now is we had the arch here as 0.8, the radius. And we will do this, we will do the same here. Yeah? We'll make that 0.8. In the end, we want to produce a symmetrical part. This is an original part. It doesn't mean it's perfect. And that's exactly what we're seeing here. This thing is not symmetrical. But we're going to produce a nice symmetrical part here.
Yeah.
So, what we want to achieve, what we're going to do is we're going to say this point to the y-axis is symmetrical to this point. Oop, didn't want that. Let's try again. This point. Okay, why does it not like? We didn't hit the y-axis, that's why. Y-axis, this point. Symmetrical. Good, that worked. And now we have too many constraints. Yeah? It says that one of the constraints is too many because we doubly defined something. Please remember at least one of the following. One we can't remove. Let's go from the back. So it says 15, 16, 17.
Yeah.
Let's try 15. And we press the delete key, and that's it. We're not doubly defined anymore. Good. What would be a good idea is if we define how many degrees this thing has. Yeah. So at the moment, this runs through 236 degrees. Yeah.
Right. Yeah.
Could say 240. Let's see where that ends up. That isn't bad, actually. It's a good point. And we do the same for this one. We also say this is 240 degrees. That will guarantee that the whole thing will be symmetrical. Okay? Yeah. Now we will do that center line. So that basically goes from here to here. And we want this thing to be the 2 points symmetrical to the y-axis.
Yeah.
So here we go. That's symmetrical. And you can see the part isn't. Even though we totally hit the radiuses here, the centers of the holes on the head, the part isn't exactly symmetrical, but that's fine. It's a 1930s watch part. That's what you expect. They never had a view of the part and in this scale. Okay, and now we got to guess here a bit. These are, again, we make those segments a circle segment 1 and 2. Okay, that lifts it up. And we do the same here. 1 and 2. All right, so that's joined. And now we got to make these even as well, because this has to be symmetrical to the y-axis. Boop. Done. So we got the symmetry up here. That means here, there we go. That's highlighted. That's symmetrical, and that's pretty well defined. If constructively this is a slightly different arch than the original, yeah, So we could try and go out a bit here with symmetrical. See, there you go. But we now see the part isn't symmetrical. Yeah?
Yeah.
So on the right-hand side, it
There's a lot
doesn't
more
quite
space
add up.
underneath there,
On the left-hand side, it does more, so we got to find middle ground here. We are perfectly symmetrical. We know that. There we go. Yeah?
Yeah.
That's pretty good. Good time to save. We don't want to lose this thing. Now we go back to the model. We got a sketch. We want to make this thing a pad. So we basically just say we're going now into part design. And we finish editing the sketch. There we are. So we go back to the model. We got a sketch. And now we add a pad. This is where 2D becomes 3D. And now we've measured it. It's 0.67 thick. Yeah?
Yeah.
0.67 millimeter thick. Here we are, failed to validate broken face. That means somewhere in our sketch, Marcus, Okay, so we have a problem. We don't have an object that has just one outside border. We have somewhere a gap. And we got to find it. What we do is we zoom in like Total Madman, and we follow the outside line. So we go over here to the, and there it is. See, we've already found it. So what we got to do now is we got to join these blighters. We just put a constraint in here, and now we have an obsolete constraint. Again, we go back to, it says 25. We got to check this. This constraint here is the one, because we defined a length, and we got to take that one off. Yeah, the constraint of the length, I'll zoom out a bit. There we go. So what we have is the length here, this one, yeah, is constraint number, does this not get selected? 3.6. That's the one. So we're going to take that one and delete it. It's still moaning, and 18 is apparently redundant as well. So we take 18 and delete it as well. And now, hang on, I thought we deleted 18. There we go. And now the dots have magically joined. And now we check the other side. So good thing here to zoom in. That will show you, let's go mad here. That is really joined, yes, it is really joined up. And we follow around, go up and over. That looks good, that looks good. That looks all joined up. Yeah. Okay, so with a bit of luck, we will now be able to get a pad out of this, a 3D object. And you can see now it doesn't show an error anymore. We have a 3D object. And here we go. Beautiful. Couple of things we got to do now. We have to drill a hole in here. In this phase, we got to drill a hole for the winding stem, centered. Okay? So what we do now is we add a sketch to this. Oh, you need a planar face. Support for the sketch, yes. Ah, this isn't a planar face, it's bent.
So you use the flat end.
Yeah, but yes, I could, that's right. I could turn and hopefully we need a mouse for this. Okay, so we got a mouse connected. We can turn this thing now. And now we say we want this face as a sketch. There we go. And it worked. Okay. This is a hole. So let's zoom in a bit. There we go. We know this thing is centered in both ways. So it sits in the middle like this. And the diameter we'll check in a sec. Yeah. Yeah, what is it?
The diameter of the stem is 0.38.
Okay, 0.38. I would say, oh, I shouldn't have done that. That I got to delete. That was the wrong constraint. Delete. let's go and see what it has. Okay, 0.38 would be 0.14, but this thing has to sit with a bit. This gives us 2 100ths shake, and that's probably just about right, I would say. Yeah?
Yeah.
And now we sort of got to drill this thing.
So should that be 0.2 then?
Oh, sorry, it's 0.38. Oh, yes. I'm sorry, absolutely right. 0.2. Good stuff. Ooh, all right. And with slightly too high, we can see that. We move that down a tiny bit, yeah? So we're centered. Good. Okay.
Yep.
Close. And now we're gonna select the circle and we're gonna drill through, so to say. So we create a pocket. And yeah, 5 mil is of course more than the part has. It has about 1.5. So I just say 2 mil, that's more than enough. And if we turn this around, we can see the hole goes through perfectly.
Yeah.
Yeah? Good. Okay. Now comes the fun part. Well, actually, we could draw that this is actually that the screws are sunk in here, but it doesn't really make a lot of sense. We're just going to do that with a conical burr, and this isn't CNC. We just go on top with a conical burr and go and do that by hand. It's not worth machining that. I mean, we could, but then it's a tool change in the tool path or whatever. So we can say we're done here and save it. If it were sunk in, we would do that in the drawing because then the end mill would do the sink.
Yeah.
But as it is conical, we'll just do that with the burr at the end in the machine by hand, more or less. So we guide the machine by hand and that's it. Okay. Now we need a tool path to make this thing. And we got to think of what tool we need. So the holes were what diameter?
The thread was 0.6.
And we made them, let's go back to the sketch, we'll have a look. We made the holes
0.8, is that it?
0.8. So that's cool, because we can use, the bigger the mill that we can use, the faster, the better, the easier to do this thing. And 0.8 is a big mill, so that's cool. Okay, we close it, and now we say we go to path. Good stuff. And we want a new toolpath, create a path object. Here we go, based on our body, and that's it. This box here gives us the material dimensions. And as you can see, it's higher than the piece, and we don't have that. We have exactly the same material height as the object. Now the box is exactly as high as the object is. Yeah? And we got to choose a tool. We say add. And I don't have one here, so we just make one. So 0.8 millimeter end mill. It is an end mill, it's carbide, that doesn't really matter. 0.8 millimeter diameter, and the cutting height just has to be more than the, it's millimeters fine, it has to be more than the height of the object. And yes, that's the case, so that the mill can do it. So that's fine, we've defined it, we click on it and we say create tool controllers and then okay. And that means we now have a new tool here. The default tool we remove, we're not going to use that. So that's all we need for the setup. Now comes the important bit, the setup sheet. This tells us where the tool starts. What we want to do is when we mill this, we go onto the center with our tool and put it exactly on the top surface of the material. That will be 0.0. And we mill down from 0.0. Okay, so what we see, the final depth has to be the height, which was 0.67, but we're going to give that more because we will also mill into, we're going to glue our brass onto some wood, and we will go further to make sure that we cut all the way through, meaning we will go for 0.9 millimeter final depth. Start depth is, as we said, 0. Now comes the interesting thing, tool, the step down. This is brass. If it were stainless steel, we would probably go for 100th each step. So meaning it goes around, it steps down, it goes around, it steps down, it goes around, it steps down. So what we do now is It's brass, so we can go for about 20% of the tool diameter. The tool diameter is 0.8. We can go for 0.3, yeah? 0.3 millimeter step down, meaning in 3 runs we've done the part.
Yeah.
It does 0.3, 0.6, 0.9, and it's done. Okay. Now, what we also have to define is spindle speed. With that sort of tool, we go full pelt, 24,000. And we define a horizontal and a vertical feed. Horizontal feed is milling around the shape. And again, in steel, I would say we go about 0.1 max. But this is brass. We can probably go 0.2 millimeters per second. And vertical feed, we can go 0.2 as well. We could probably go a lot higher. If we would go millimeter a second, it would still mill nicely.
Yeah.
But
Small part anyway.
it's all about tool life.
Yeah.
Time is of really no essence doing this. It doesn't matter. Okay, so it's important that you define all this before you define what you do. So you got to have your tool defined, and you got to have your setup sheet right, final depth, start depth, and the step down. If you modify that afterwards, it does not modify the operations you have defined. You got to delete them and redefine them. So now we can get to the operations. We have a couple of choices here. That's the shape around. This is pockets. This is drilling. This is a pocket. This is drilling. This is engraving. What we want to do first is the holes, because once we have cut out, the object pops out from the glue and we can't do anything. So we got to drill the holes first. So we say drilling is first, and we're going to add 1 hole at a time, because if we have both holes, it will go 0.3, get out of the first hole, go into the other hole, do 0.3, jump. So we're going to want to do that in one go. So we click on the first hole and we say add. So it says fine, that's the 0.7. We've shot ourselves in the foot. I thought it was 0.8. How can that be 0.7?
Yeah, because it was 0.8 was a radius.
It
should be 1 point.
0.4 radius, so it should be 0.8 diameter. And it says 0.7. Okay, what we do, we cancel the operation. We go to the sketch and we verify what we have, 0.8 millimeter. And 0.8 millimeter, definitely. Okay, do we have the tool defined wrongly? The tool, that's the horizontal, okay, and it says 0.8, where's the diameter? Let's go to the tool list and look it up. 0.8. Just a sec, let me stop. So the diameter is correct. See, diameter 0.8. Carbide, all fine. So that can't be it. Okay, we'll try this again. Let's try the other hole first. Okay, we want to drill. And base geometry, we add the hole. 0.7. Okay, let's see if it will do it or not. That's proof is in the pudding. Okay, retract. Retract height, that's also important. Before the machine drills, it'll go above the workpiece by retract height and then start drilling. As we've got a really, really slow feed, you have to wait minutes and minutes till it goes from 10 millimeter to drilling the hole. We don't need that. 0.2 mil is absolutely fine. That's all
just
it
the height
needs.
from the zero position as it goes across.
Exactly.
Yeah.
So that's fine. All the rest we have, we say okay. And now we have a drilling operation, and now we check if it does anything. It does. It does do the hole with the 0.8, so fine, that's good. This is a bit odd.
Touch the surface.
It says it's touching the surface. Okay, let's see what we got here. That's probably the retract height. Should be fine. 0.2 millimeter. Okay, fine. We'll leave that as it is for the time being. Now we add the second drilling operation. This hole, base geometry, add. There it is, 0.7 it says. We will totally ignore that. What we also want now is the retract height. Let's set it to 0.3, just out of curiosity.
Yeah.
See if it does anything. Got that, and we will check what it does. Boop, boop. Shows a bit less. Yeah, but this is definitely a positive measure, meaning it goes up. I don't quite get it. Never mind, we'll ignore it. Worst case, we break the tool. Now, this we can't do in this operation because we can't drill sideways. So the next operation we do is the contour. So we say create contour path. There's our 0.8, and we don't need extra offset. That would be for if you have a spindle runoff or something like that, which we don't have. Start depth 0, going down to 0.9, steps of 0.3, totally correct. Safe height, clearance height, yeah, fine, good. And in we go, direction counterclockwise. Good. In we go, and we can see it has that path, and now we watch the whole operation. First hole, second hole, around once. I didn't like that. It has to go around 3 times.
Yeah.
So what happened? Contour. It says minus 0.9. That's where we're totally wrong. Okay. That means if you don't get the setup right, you have to delete all your operations, which we will do. No problem. Because they're easily set up, and that's maybe where problems came from. The cut material we delete as well, and we have our workpiece again. And now we set up the stock correct. What we did, we said 0.9, that's above the workpiece. That's minus 0.9 millimeter. That's to as human, good. And now we drill again. Base geometry. Yeah, we only want 1 hole at the time. Yeah, and we also want that height here at 0.2 millimeter. Otherwise, we're going to wait forever. Okay, and now we watch that and see what it does this time. Well, still does that. We'll ignore that. And we want to drill the second hole. Cancel. I'm going to get rid of the cut material first because I can't see what I'm doing. And now we're drilling. Did we do this one? I don't know which way. Yeah, it's okay. We'll watch it. No, we did the right one. Good. So we're going to drill. No, wrong operation, not pocket. Drill this hole, and it knows that already. We do 0.2 millimeter here. We apply, and now we do the contour here, and I don't know where that's highlighted, but we don't care. And we go for the contour. Now we watch what it does. 1, 2, 3. That representation isn't right, that it cuts all the depth.
So it doesn't show you the right height.
That isn't correct. The Lord knows why. It doesn't matter. But we're there, pretty much. So we have a complete toolpath for all 3 operations, 2 holes, contour. Now we want to export that. We can use it on the machine. So this is, of course, in our folder where the part is. And what I do, I name it after the tool I use, 0.8 millimeter path.text. No? And then I know exactly what it's for. I know I will have the right tool. There is an error in the FreeCad centroid, the bit of the program that makes the machine G code has an error, and it says G20, and that means it would do inches. Yeah. Times 25, it would totally knock the back of the machine. So you have to make that G20. Now we're going to go through and see if things are halfway correct here. It says it starts the motor up to 24,000, that's good. It goes to Z position 5, so it goes up pretty high, yeah. And then it starts drilling, and the retract height is 0.2, meaning it will start drilling at 0.2 and then go down speed 12 to Z minus 0.9. That's correct. It drills a hole 0.9 mil into the material. Then it does that. The same thing with the next drill. And then we have the toolpath for the contour. What we do here, it says it goes to Z3, and then it would slowly descend, and we'd be standing here for 2 minutes. We just say G0, Z 0.4. 1, meaning it goes to a tenth above the workpiece, and then it descends to minus 0.3, and then it starts working on the contour. That just speeds things up.
Yeah.
And then we just sanity check, 0.3, 0.6, 0.9, speed 12, so F12, that's okay for brass. In stainless steel, that would ring alarm bells. Without cooling, you couldn't do that. Okay, we're done.
Good.
So we've made the part, we've got the contour path, we can go ahead and make it in the middle.